Hey everyone. So we have Ethan up on the stage, guys. Let's get this going. So it's Ethan's morning. He's in Asia time zone, and I want to tell a story a little bit about how I met Ethan. I was in Singapore, and he was at the Vitalik event for bittensor, and I didn't know who he was, but we were talking about training mechanisms, specifically around subnet 9 and 6. And Ethan was in the room and started talking to him, but I didn't know who he was. And he told me how to break the subnet 9 and 6 mechanism, and that actually his team had been for a couple of weeks taking the top slot on 9 and 6, which is really hard. So subnet 9 and 6 are, for those that don't know, they're training mechanisms where the idea is to submit a model which reduces the loss on some data set. On 6, it's a synthetic data set pulled from subnet 18, and 9 is a massive unlabeled pre-training data set called Falcon. And in both cases, you have to apply a lot of amazing. You have to apply pretty standard techniques for training machine learning models, but in a competitive environment. So if you don't have all the tricks up your sleeve, you can't compete. So obviously, Ethan, who we'll hear it from in a moment, knows all about that stuff. But there was 2 points. There was 2 really interesting things. The first thing was that Ethan had discovered that there was a way to inject a multiplication into the weights of the top machine learning model, the one that they trained, such that no other teams were able to fine tune their model after the fact, but still made their model really powerful. And the way that this worked was that if they blew up the weights on one layer of the machine learning model and then divided them on the next layer, they could keep the outputs, the output logics, the same of the same for that machine learning model. But if somebody were to try to take that model and merge it with other models or fine tune it beyond the point that they had submitted it at, they wouldn't be able to because they'd have exploding gradients. I thought that was really brilliant because I'd never thought of that. I'm always fascinated by people that can break systems like we build on bittensor, because they're often the people that are the best at producing systems that are unbreakable. It's a certain type of mind, and there's a certain brilliance that is required. And of course, I didn't know who Ethan was, but he's he was quite famous, and he is quite famous. He's the CEO of MyShell, and he is a perfect example. The second point I'd like to make is he's a perfect example of the type of person and team and company that we can work with at bittensor. Using incentives directly attract that type of talent, that quality of talent, to minimize the loss on a machine learning model or improve the inference speed of something where we would have no idea how to do this in practice. We can go with our eyelids as wide as possible out into the world and attract these geniuses to come and solve problems together with us collectively. The end of the story here is that we're working on a fix in subnet 9 so that this can't be done, and that we can foster more collaboration between models. But that's how we met, and ever since then, I've been really hoping that he and his team build a subnet, and specifically around training, because they're the best in the world when it comes to text-to-speech models. And yeah, so without further ado, Ethan, thanks so much for coming on the call, and I want to talk to you about, well, that event. Tell us more about what it's like to fine-tune and train machine learning models on bittensor, and let's use that as a segue to go into talk about your subnet. So yeah, thanks, man.
Yeah, thanks, Jacob, for having me. Hi, on the BitTensor community. Yeah, so basically, I think we met BitTensor probably in early February. The whole experience is kind of fascinating. Basically, my researcher and I just surfing randomly on the internet, so we saw the BitTensor. I think the all the documents of BitTensor is kind of the starting point. But the things getting more interesting is after we discovered the subnet mechanism and also the tostnet. So everything become a playground of the training games. I think because our team has like over 10 years of experiences in the AI space, especially for training different models, both covering very early CNNs and also the nowadays the transformer models. So we realized that in big tensors there are actually 32 parallel subnet targeting different questions, and also the question is quite flexible. So all the 32 subnets has totally different problem defined and also having different metrics to evaluate the miner's work to see who is doing better. So we went through all the subnet and saw that 6 and 9 is something that we have the expertise on. So my researcher basically trying to do the model training and trying to get the top on the leaderboard. And basically, I think majority of the subnets, especially those targeting for the model training, is more like an incentivized version of Kaggle. But yeah, so Kaggle is quite famous in the traditional Web2 AI space because it's just hosting regular computation for people to submitting different models in different verticals. So, but there isn't huge incentive like the how BitTensor is providing for, and there isn't a huge community that people talking all about this. So I think BitTensor is pretty sure is much better and more flexible version of Kaggle, at least for the model for the AI researcher and the model community. So yeah, so that's how we met BitTensor and the interesting stories. And after we are getting intrigued by the bit answer mechanism, we are thinking, wow, why not we just we're hosting another subnets targeting some of the audio domains that our teams has been so familiar with. So here comes the subnet 3, and we saw that after the subnet 3 is launched up after 2 weeks, it's getting super competitive. There are a lot of miners to train to do the model fine tuning based on the models and the open source algorithm we provide. It's based on Melo TTS, which is a real time text to speech model that's gonna be able to run in real time on CPU. So we open sourced the model about 1 month ago and getting a lot of tractions. So the subnet 3 is doing the fine tuning based on the open source repos we have.
Thanks, Ethan. There's a lot. We're gonna have to jump into exactly how subnet 3 works, but before we get there, can you tell us about how you beat the mechanism on 9 and 6? I always find this really interesting to hear from how miners approach these problems and like what you uh, put behind that challenge.
Yeah, I think 6 and 9 are kind of different. So we initially when we first initially thinking about the subnet, I think we are looking at the code, how the evaluation works, what's the model architecture. So there are multiple ways to actually either break the system back then or win the computation. The way to break it, I think initially subnets I forgot 6 or 9. They forgot to restrict the model architecture. So basically, you can use a quite different model architecture that has bidirectional message passing. So in that sense, basically for every questions, you can read it. So you can read the answer, and then you basically have zero loss. And I think the subnet owner quickly fixed that probably over the night.
We're talking about something like BERT, right?
Yeah.
Bidirectional encoders. Yeah, absolutely, right. So, uh, for the audience, the people that don't know this specific thing in machine learning, transformers, classic transformers, will go left to right by reading the sentence, but some will produce uh, the next token by looking they're not necessarily left to right, they're more full context productions of the tokens. That's right, Ethan. So like BERT, for instance, looks at the full context, looks at the whole sentence to predict particular tokens in it. And this is useful for producing embeddings. So if we're looking for your loss on the next token, but you can know what the next token is, you get a zero loss. And that was one of the initial exploits that came out on subnet 9, correct?
Yeah, that's the initial exploit, and I think the team quickly fixed it over the night. So it only gonna mine with this mechanism for a few hours. I think after that, it's getting super. I think as more and more people knows bittensor, it's getting more and more competitive. So it's really all about how to overfitting the data and how to do the training efficiently. So basically, our researchers set up the training pipeline and quickly find out that if you submit a model and the model is indeed the best performance models, some guy gonna do the fine tuning based on your model, so it's gonna do a little bit better. That's how we came up the mechanism to prevent people actually doing the further fine tuning. So I think because this mechanism it's kind of fun because very few company or the open source model thinking about this mechanism. I think only Mistral models had the so-called watermark to prevent other people doing the further fine tuning. But actually, I mean, we need to figure out how it's works. So the ideas you mentioned is doing the multiples and dividends in some of the random layers. It's something that we came up. And then later, I think right now 6 and 9 is getting more super competitive. People having all different hacks and tricks trying to train on these kind of watermark models, and then have a more fancy algorithms or ways to prevent people training on top of it. So it's getting more and more interesting.
And I think that as designers of training subnets, we have to work with this type of competition to push people towards not making it so that there can't be combinatorial collaboration between the models. Excuse me. But if we can actually get it to work, we've invented just a really powerful distributed training mechanism, in the sense that if people are using other models as their breakoff point, we're actually all training the same model. We're just using there is no like centralized coordination happening with say a parameter server. So I think this is being solved on subnet 9, and it's really cool to see that people were doing that. They were taking the top models, fine-tuning them more, which would be very much like in a training pipeline if there was a checkpoint, and then we take the checkpoint and we go to the next state. So just one more question about when you guys were training on 6 and 9. After you discovered these exploits and then they got patched and you did train a model that was really performant. How did you approach that problem? Like, what kind of compute did MyShell bring to the task, and like, how many people were working on your team?
Yeah. Just to clarify, it's not actually our the company or the projects backing this kind of training and mining on the subnet. It's actually our researchers, just his hobby to train this. Basically, I think he has like a 16 H100, so that's all the compute he have, and just one guy's doing that.
Which is amazing, because when we were looking in the Discord channel, at this time, people were saying, oh, there's no way that you can train a model of this size with this amount of incentive. You need a whole data center. But then you have really high quality engineers that can figure out how to do these things way cheaper. And I think it really showcases what incentivization can do. Where there's a will, there's a way. Where there's incentive, there's even more of a way. And so, yeah, 16 H100s is nothing for them to get that top spot. But at the end of the day, it was the lowest loss. So, bang for buck, it really shows that these incentivization systems, these training mechanisms, can get the lowest loss for the least cost. Maybe 100 times better than what a centralized company can do, which is really cool. We're not there yet in terms of monetizing it, but maybe this is something we will talk about in the rest of this presentation. So after you went and did this, Ethan, we'll use your research team, you guys had this idea to cook up a subnet of your own. So let's talk about what that subnet is and what makes it unique in the bittensor ecosystem.
Yeah, so I think during the experiences to working with I mean especially digging the code of subnet 6 and 9, I think especially subnet 6 give us a lot of inspirations and know-hows about how the bittensor ecosystem works, especially this kind of ways for people submitting the models and doing the model evaluations. So we just went through the subnet list and didn't see a good ones to actually incentivizing people to solve the issue of like voice call and text to speech. These are two typical problem defined in the audio domains for generating high quality and high fidelity human voices. So yeah, so I think at the earliest time of my show, we want to build a multi-modality creator platform for everyone to build the AI applications. The voice part is missing, or the 11 apps is so expensive to use in the chatbot scenarios. So that's why we get started building our own models and making it open source. So I think this problem also making us very familiar with different audio models. So we want to build a subnet that's targeting these issues and also leveraging the bittensor mechanism and the community to to build the model and further fine tuning it in a collaborative scenarios. So we have the subnet 3 that has similar code structures as 6, but it's targeting and evaluating the audio model, both for the speaker similarities and also for the text-to-speech clarities.
So let me just translate that. So subnet 3, it's very similar to 9 and 6. It's a training mechanism. However, there's something that's unique about it, if I understand correctly, from our previous conversation, is that in 6 we're doing fine-tuning. In 9 we're doing pre-training from a large corpus. 6 is obviously synthetic data, but in 3 there are a set of what was the word you used? They're like features of audio that when you ask the miners to generate some text, you have already pre-recorded the features that you want that audio to have based on the voice of some particular individual or some other type of audio. Is that correct? So it's like Elon Musk, we look at Elon Musk's voice and we say, hey, there's, you know, this type of pitch and this tempo, and then we're going to ask the miners to produce audio that's like Elon Musk and get the responses, and then we check it against these features. Is that correct?
Yeah, so basically, I mean, for the model, so for the miners, they just submit the models, and for the validators, there's an evaluation metric we set for these questions. And for now, there are two types of evaluation metric. The first one is the speaker similarity. It's basically how similar the model's generated voice is sounds the same. I mean, sounds similar to the original speaker. Like let's say Elon Musk. If the speaker is drawn, that the challenge become the model have to generate the voice of specific sentence that's using Elon's voices. So the first evaluation metric is how similar it is. So the metrics defined on a feature extractor. So we have a small models gonna extract the speaker feature based on the audios. So we're gonna compare the features similarities. The next part is for the next part is actually for the audio clarity. It's basically the model has the input. It's the text that should be generated into the audio format. So we also gonna run the Whisper model, which is the ASR model, which stands for automatic speech recognition. Gonna try to recognize what's the content in the generated audio. We're gonna compare the text as input and also recognized result to see how good is the audio generated.
So you have features that check for tempo, tone, but also whether or not what's being produced is actually what is point, and then they're each individually checked against these voice categories. Is that right, or is it multiple models? And what are the current categories that we can generate at this point?
Yeah, so There are gonna be different evaluation metrics, as I mentioned, and we're gonna add more and more. I think right now it's evaluating the speaker similarity, the clarity of the audio, and but we noticed that in recent top models has a lot of electric noises inside it. So we are considering to adding another metrics to trying to incentivize the people, not just targeting existing metrics, but also generating good enough models for production usages. So we're actually constantly changing and monitoring what's happening in the top performance models and want to find a way or define new evaluation metrics to actually make that happen. So that's what's happening right now. And for the speaker part, I think right now there's only one speakers, and as people getting overfitting on the fixed data set, we're gonna introduce more speakers. So to make the model more generic, and then in the end we're gonna make the question pivot to a generic models that's gonna be the all-in-one models that's gonna simultaneously do the voice cloning and also text to speech and also multilingual translation. So that's gonna be the long-term vision and end goal for the subnet stream.
So we'll have multilingual translation, have multiple voices. And where would this stack up against something like 11 Labs if we were to accomplish all these tasks?
Yeah, so basically we're gonna have an open source version of 11 Labs and much faster version.
And we can also take this. I understand that there's some coordination potentially between this subnet and the audio network, where we can inference these models, because it's another aspect. They're not that big though. If I understand correctly, audio models are much smaller. Like they're not 100 billion parameter foundation models.
Yeah. I think audio model is much smaller. At least for now, it's using variational encoders. But I think as this kind of model architecture reaching its full potential, we're gonna increase the model size and also trying to shift it to more transformer-based models. So it's gonna need more compute, but has higher potential. So I think for now, we just want to lower the barrier for people to enter subnet 3 to start the fine-tuning and caring about all the audio issues. And so just say what's gonna happen for the following. Yeah.
So where are we right now? So Subnet 3 is live. People are training models. Is there anything that we can look at to see how these models are working at this point? Are people able to train decent models so far?
Yeah, sure. So basically, on my show, I mean, we are hosting a lot of different models, and we're gonna make it more permissionless, so everyone can upload their models. So for now, we have just uploaded one of the top performance models on subnet 3, but in the future we're gonna automatically to pull the best models in bittensor ecosystem on my shell. So our creator community has the access to using the model easily without deploying the models themselves. So it's gonna be easily for people to know what bittensor is and also to access bittensor's top performance model in each of the subnet, and to foster the creator community to actually build applications, not just using the raw models. So I think that's really gonna foster the real usages of all the great work that bittensor is incentivized for.
We could at a certain point move to larger transformer models on text to speech. What is the ultimate goal for text to speech in your mind? Where do we go? Like what is the ultimate text to speech model capable of doing? I guess parroting every single individual on Earth and singing beautifully and making rap songs and beating out Biggie Smalls.
Yeah, I think the end goal for the text-to-speech model is probably it can only leverage like 10 seconds of any speaker's voice in any languages and generates any text and sing in another in any language. It just and sounds so natural. A person is talking to you, and AI can fake it. So we have the audio part for the matrix.
Sorry, I was muted. We have the audio part with the Matrix. Absolutely, you're gonna trap me inside of a virtual reality with a beautiful sounding woman. Ethan, so my shell, how does this play into the vision for my shell? Like, how is my shell going to be using this bittensor subnet?
Yeah, so I think the general idea for my share is that we saw the I mean, after the stable diffusion, the large language model, we saw the potential of non-technical people to building softwares easily without codings at all. So we built my shell. It has seen multiple parts. The first part is gonna be a lot of models that we host and gonna be it's readily used by the creators to build applications. So back then, I mean, there isn't much high quality open source models. So that's why we build our own audio models and also make it open source, because we always believe in the open source development in this kind of AI era. So yeah, so we want to cover as many as possible models out there on GitHub and also on Hugging Face. So with all these models, the creator has more flexibility to build a concrete use case and publish it on MyShell platform. So and also we're gonna help the creator to monetize through tokenomics and all the crypto incentive part. I think the good part of the bittensor is that previously our research team has to dedicate it on building the models and updating the models. But with the incentive from the bittensor and also the mechanism how the subnet works, I think in the future, if there is an important domain that we're gonna want to spend our engineers and our research and engineers efforts in, we only have to define the problem, setting up the data set, and do the initial training. And after that, it's all the subnets, the job, and also the bittensor community member can join to pushing forward the model's capabilities. So we can just keep our engineer and research team effort to targeting the real questions rather than spending a lot of time updating the models. And then we can leverage the bittensor's people's intelligence to have a better and better models over the time. And so on my shell, we also gonna have the best model capabilities out there. So that's the synergy I saw between the bittensor and also my shell.
When it comes to training mechanisms, specifically on bittensor, and you have experience across 3 of them now, building one, let's say beating 2. And where do you think bittensor subnets can improve, just in general, with the training mechanisms? Like, one of the questions I have is how to better combine the models that are being trained so that there's more collaboration. So things like, say, limiting the ability for people to change the architecture or to add this boosting of one layer and subtracting the other layer to stop from fine tuning. Where do you think subnet 3 can go, or even subnet 6? We have Technium here for subnet 6. Where can we go to make these things more collaborative or improve them just in general? Like, where do you think that that would be?
Yeah, I think probably one thing we can do is that trying to lower the barrier for more AI background people to understand the bittensor and also to get started easily. Because I still remember I spent like a few hours to get the all the validators code running up. I think probably we can have like Docker or something like that as a standard template. So people with zero background in crypto and also with bittensor can also get started. So that's gonna bring in a lot more talents in the domain to compete for better performance models or for building something that's genius. So I think that's probably the thing that I think gonna help with the bittensor ecosystem.
So more miners, driving them into these incentive mechanisms and
Yeah.
giving yourself more competition.
Yeah.
On your subnet, on subnet 3, have miners trained anything that my shell has not been able to yet?
I mean, yeah. I mean, of course, it's better. It's much better than our initial base models because the currently is still incentivizing people doing fine tuning. But I think after like 1 or 2 days, there's some very strong researchers. I don't know who that is, but obviously he knows a lot about the training part. So he's producing very high quality models. But I think the metrics part is kind of not that not that great. So we are updating the evaluation metrics to incentivize him, not just beating the subnet, but rather also building a very useful models that we can deploy on Vidya.
It's always an interesting experience when you're a subnet owner and you discover that there's people out there that you don't know that are one step or two steps in front of you, and you start scrambling because you're like, how am I going to beat these people that are somewhat better than me and also hidden? They can see everything I'm doing. I can't see everything that they're doing. And so there's an asymmetry in the battle between the owners of the subnets and the miners. But it sounds like what's happened is you guys need to expand your feature set so that the miners are just not overfitting. And like, how will you guys approach this problem of expanding the feature set maybe indefinitely or like in an abstract sense so that it's just not possible for that to happen?
Yeah. I think we talked a lot on this issue, how to automatically have some data and also expanding the validation set. I think for now we're just gonna expanding it with our preparatory data set, because previously during the initial training phase, we have collaborated with a few data labeling companies for a more broader speaker data set base. We have I think we internally have over like 10,000 different speakers data for for the audio problem. So we're gonna gradually adding some of the internal data to the subnet. I think, but in the end, I think automatically scraping, let's say Spotify for the new podcast, and also the YouTube, finding the clear background videos and audios, gonna be a automatic ways to scaling this kind of data sets and also evaluation metrics to really incentivizing some generic models that not just doing the fine tune doing the overfitting, but it's gonna have the generic capabilities to do well in some of the data that's unseen. So that's the direction we are going for.
Yeah, this is a great opportunity also to use other subnets within inside of bittensor, right? This is what Technium and Emozilla did with Subnet 18. They were like, how can we generate an infinite set of synthetic or like new data that the miners can't fine tune on? And as you said, exactly, like that's where using a subnet that, for instance, scraping YouTube or Spotify and podcasts or even this podcast to get audio samples and then using that as the validation mechanism is going to be essential for subnet 3 to really hammer out the mechanism, the incentive mechanism, and force it to these shadowy crypto machine learning engineers. Crazy archetype, by the way. Shadowy crypto AI engineers. What have we created? But anyways, so you have to be able to have this infinite set of data. And I wonder if maybe the Omega guys in 24 or other scraping subnets like 13 perhaps can help you guys accomplish that aim and do some cross subnet pollination. So if there's anyone who's working on one of those subnets that wants to reach out to Ethan, this is his first day on Discord. So he's now here to talk with you guys.
Yeah.
Oh, sorry, first day with AMA on Discord. Pardon me. Obviously, you've been here before.
Yeah, I think there are different kind of subnets. Some of this like is incentivizing people submitting the models, so it's a model subnet. And others is I think there are a lot of data subnet. I think there are gonna be really some real synergies between all those kind of model subnet and also data subnet to work together.
Mm-hmm. Absolutely. Okay. Ethan, thank you so much for coming on the stage. At this point, we're just going to transition the podcast to answering questions from the community. If anyone else wants to come on stage and ask questions to Ethan, put your hand up. I think you just go try to join the stage, and I can bring you up if you want to talk, or if you just have some questions, you can put them in the novelty search channel here on the right hand side. Anybody, let me know. Techneem, if you want to come up and talk about the 6, how 6 is related to this or different. And maybe you have some advice for Ethan on how to make this work. Or not. Okay, I guess. Well, there's so many types of questions, but if Techneem can't, no worries. Well, then in that case, no questions. But it was a great talk, really interesting to dive into this text-to-speech, Ethan, and you guys are doing an amazing job. I can't wait to see this AI girlfriend created for other people. And yeah, okay, guys. Thanks so much, everyone. Have a good day. Ciao.
Yeah, thanks, Sarah.
Well, there goes the novelty search, I guess. Which means I guess I should probably start like working on things. That's cool though. Actually, I might start see if I can set up a tile miner over there. As you might have seen, like that's a topic that's very interesting to me. So we did get this all hats doublet though. Well, while everything else went down, which is very cool. It must be the luck here that's doing it. Okay, so that's... Okay, I gotta check in and see. Oh yeah, I got one of these. Sure. Not that one though. Can I undo? Weird. Let's go to quest here and let's do this. Did I sell a knife? I don't remember if I did. Maybe I did. What's this? Is this damage? DR. Okay, I can dump that. That's fine. Keep that though. Okay, so Frost Mountain and caves, frost twice. Caves again. Yeah, okay, so it's probably frost or caves. Well, I guess I feel like I will probably just like wrap it up here and then maybe go work on some stuff and then maybe jump back on later. I guess I'll check in with chat because it never showed up on Arc. I don't know why. Let's see. 2 viewers, hello Twitch. Let's check restream. Okay. Well, we'll wrap it up there, GG friends. I will catch you again soon.